Hello class, this is the fourth and final video on the generalized pigeonhole principle. So let's get straight into this final example. So a grade of 500 students are voting for a school captain. The person with the most votes wins. So it's not a democracy where we need more than half voting. So it's just the person with the most votes will win. Okay, most votes. So if there are 7 candidates running for school captain, what is the minimum number of votes needed to win? Okay, so once again, let's find the positions, and the objects. So for this, the positions are very clearly the 7 different candidates, and the number of objects that we have to divide are the 500 students voting. If we were to divide this as equally as possible, 500 divided 7, well, that's going to be 70 something, I believe. Yep, 71. 71.428, etc. Okay, so now, if everyone voted as equally as possible, well then, 71 times 7 people, 7 candidates. Let's take a look at what would happen then. 71 times 7, that's 497 voters. So if we had exactly 497 voters, and they all voted equally amongst the 7 different candidates, this would give a tie. Okay, well, clearly, I hope you can see, 500 take away 497. 497. There are 3 voters. 3 voters would actually decide who wins. Because actually, let's think about this now. Here are the 7 candidates. Let's put them here. 1, like this. That's 1, 2, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So we're going to stop at this one. So let's assume that already each candidate has received 71 votes. So 71 in each of them. Okay? So each of them have already received 71 votes. Now, these 3 voters that are yet to vote, these 3 essentially decides who will win. But now, think about this. If we were to divide the 3 equally, so let's go 1, 2, 3. Then these 3 are in a tie. If 1, 2, 3 votes, then this person would win. So, what is the minimum number of votes needed to win? Well, of these 3 voters, if 1 votes here and 2 vote here, then we have a clear winner. Okay? Well, in that case, it's going to be 71 plus 2 votes. We need 73 votes. So, to simulate this a little bit further, if there are 500 people voting, and the moment that we see that everyone's voting equally amongst the 7, if we count 73 votes on 1 candidate, then they are a clear winner, assuming each of the 7 candidates gets an equal number of, equal number of votes. So I hope that gave you an insight into the generalized pigeonhole principle, especially this idea of taking the remainder or multiplying the whole number and subtracting from the total number of objects. That's true for this one here. As you can see, drawing a diagram sometimes will help. And for this one as well, we're taking only the decimals or the remainders. And we saw that here as well. So I hope that gave you an insight into the generalized pigeonhole principle. I hope to see you in the next video. Best of luck.